If arithmetic progressions have a common difference, geometric progressions will have instead a common ratio. Look at this one over here. Here are the terms of this geometric progression, and what is happening. If you divide one term by its previous term, the ratio is going to be the same, it's going to be common. In this case, it's 2. 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, and so forth. All right? Again, here you have the term's position. So I'm just going over what the letters mean. The A again stands for the first term. R stands now for the common ratio. You no longer have the D. It's the R for common ratio. L still stands for the last term. And then, knowing this, what is going to be the general term? Is going to be A times R to the power of n minus 1. So let's say that we want to get the value of the fourth term of that sequence. If we know A, which is 4, and if we know R, which is 2, we can get it. 4 times 2 to the power of 4 minus 1, which is 3. So that is 4 times 8, which is 32. All right? What about the sum of all the terms in a geometric sequence? For that, you will use this expression over here. Again, all you need to know is A, R, and N. So let's say that we want to get the sum of all those terms. It's just a matter of substituting. 4, open brackets, 1 minus 2 to the power of 5, close brackets, divided by 1 minus 2. That is going to be 124. If you want to bother to add all of that, you will see that that is the result. In some situations, R, the common ratio, is going to be comprehended between the values minus 1 and 1. If this happens, the common ratio is going to be such that the values of the sequence are going to be fractions that are going to be smaller and smaller. What does this mean? This means that if you add them, eventually, instead of diverging to an infinite number, they are going to converge to a specific number. And only on these situations, when the common ratio is in between minus 1 and 1, you are going to be able to calculate the sum to infinity. All right? You may add forever all the terms of a sequence, and instead of diverging, instead of going to infinite, you are going to a specific number. And that number is calculated using this expression over here. A, the first term, over 1 minus the common ratio.